Hi everyone. Today we will revise all the past paper questions from 2016 to 2024 related to chapter 6 electrochemistry. Before starting those questions, I will give you a brief introduction about the electrolytic cell and what is electrolyte and what are the electrodes. Okay, so this is our these are our two electrodes. You can see over here, one is anode and the other one is cathode, and this is our electrolyte. These are the three main components of an electrolytic cell. Okay, anode is always a positive charge, whereas cathode is a negative charge, right? And electrolyte is actually a compound that will be broken down using electricity. So electrolyte is usually an ionic compound in the aqueous state or maybe in the molten form. Electrolyte will give you usually two types of the ions when it will broken down, the positive ions and the negative ions. Okay, so the positive ions will move towards the opposite charge electrode, so it will move towards the cathode, whereas the negative ions will move towards the anode. At the anode, oxidation is actually taking place. So what does oxidation means? Oxidation means that the ions will lose the electrons. So whoever will come at the anode, actually that ion will lose the electrons, whereas at the cathode, when the ions will come at the cathode, they will gain the electrons. So they will gain electrons here, and they will lose the electrons. So whenever they will lose the electrons, these electrons will actually move in the external circuit. This is our external circuit. Okay, so they will move here and they will move towards the cathode. That's why cathode has electrons, and here the ions will come and gain the electrons. Okay, that's all. Now let's come towards some tips and tricks. Usually in the question, in the exam, when you get the question, they are usually about three different type of the electrolytes. Okay, that electrolyte can either be molten. Okay, for example, a molten compound, we can say NaCl. Okay, because this is a ionic compound, and it can be aqueous. Okay, so the second one, it can be aqueous, but aqueous can be either concentrated or dilute. Okay, so in exam you can get just only these three types of the electrolytes. If in exam you get molten, for example the molten NaCl, so what will be your products and where they will move? Okay, where these ions will move, we will see one by one. So for example, the first one, if you have molten, so molten has no water, right? It means it's just the melted ionic compound. So it will produce two types of the ions, sodium and chloride ions, right? So sodium ions, because it's a positive charge, so it will move, of course, towards the cathode, whereas the chloride ions will move towards the anode. And what you will get here, you will get a chlorine gas, where here you will get a sodium metal. Okay, this is, I think this is clear to you. So every time whenever you see molten, the product will be the same, which is the compound. Actually there will be two products, one will be a positive ion and one will be the positive ion that will become a metal, and the negative ion usually will become a gas. Okay, so but if you have the aqueous solutions, so if you have the aqueous solution of the electrolyte, then your product at the cathode will be, most of the time it will be hydrogen. Most of the time, or you can say 99%, it will be hydrogen at the cathode. The metal will not be deposited at the cathode. Instead you will get hydrogen. There is only one exception case in the IGCSE exam when you see the copper solution. If your aqueous solution or aqueous electrolyte is made up of copper, for example, copper sulfate or copper chloride, then it is possible that you will not get hydrogen. Instead, you will get the metal. Okay, it's only for the copper or the silver ions. Okay, only the silver ions or the copper ions, because they are less reactive, so they will move towards the cathode. Okay, because if they are less reactive, the metals which are less reactive, for them it is easy to gain the electrons, right? The metals that are very reactive, for them oxidation is more preferable. So here actually reduction is taking place, so copper can easily go there. So now let's come towards the concentrate. Okay, now that was the aqueous. Okay, I told you about the aqueous one. So for a cathode, even if it is diluted or concentrated, I already told you the cathode you will get hydrogen. Now let's come for the anode. So the anode game is decided by dilute or concentrated solutions. Okay, dilute or concentrated solutions. So if your solution is usually dilute, what you will get at the anode? You will get oxygen at the anode. Okay, if your solution is concentrated, then of course you will get the electrolyte negative ions. The negative ions in your electrolyte, for example, in NaCl, the negative ion is of course chlorine, right? So you will get the chlorine gas at the anode when it is a concentrated solution. But if it is a dilute solution, you will not get the chlorine gas, you will get the oxygen. I hope this point is clear to you. Now we can start our questions and it will be more clear to you when we will do the questions. Okay, question 1. The diagram shows an incomplete circuit. Which substance caused the lamp to light when added to the glass tube? Okay, so now these circuits we have to generate the electricity, right? So which solution can help us? Aqueous sodium chloride? Yes, because it's an ionic compound, and ionic compounds, when they are in the aqueous state or in the molten form, they can conduct electricity. So this option is right, but we can look for other options. Aqueous sugar? No, because sugar is not a covalent ionic compound, it's a covalent. So solid sodium chloride, of course, solid sodium chloride is not an option. Ionic compounds, when in solid form, they cannot conduct electricity. Solid sugar, of course not. So option A is the right option. Question number 3. Which statement about electrolysis is correct? Chemical energy is converted to electrical energy. Electrons flow through the electrolyte. Ionic compounds are broken down. Metals are formed at the positive electrodes. If you see the third option, ionic compounds are broken down, is the only right option. Because I already told you that electrons does not flow through the electrolyte. They flow through the external circuit. Okay, external circuit, the electrons will flow through the electrolyte, only ions flow. Okay, so that's why this option is wrong. Chemical energy is converted to electrical energy, wrong. We are actually using electricity to break down the chemical compound, right? So these are these should be like this one. Okay, so that's why this option is also wrong. Metals are formed at the positive electrodes, of course wrong, because metals are positive. Why the positive will be attracted toward positive? That's wrong. Okay, so this option is also wrong. So we are only left with option C. Question number 4. Which statement about electrolysis is correct? Again, electrons move through the electrolyte, wrong. Ions move through the electrolyte. Okay, we don't need to read. That's wrong. Electrons move in the external circuit. Yes, that's right. Towards the cathode. Yes, of course, they move towards the cathode from the anode. So negative ions move in the external circuit towards the anode. Negative ions move in the external circuit. Wrong. They move in the electrolyte, right? Yes, in the electrolyte and okay, towards the anode. Positive ions move through the electrolyte. Yes, that's right. Towards the anode. Again, wrong. Positive ions should move toward the cathode. So this option is also wrong. So we are only left with option B. Option B is the right option. Question number 5. Which statement about electrolysis is correct? So again, this is the same question. So we will get the same answer. Electrons move towards the cathode in the external circuit. So option B is the right option. Okay, the other options are the same. So this is the repeated question. So option B is the only right option. Question number 6. In the electrolysis diagram, oxidation is occurring at the electrode 1 and reduction at the electrode 2. So they already have told you that they did not give you the signs, right? The negative or positive. You have to decide based on the information. The information says oxidation is occurring at electrode 1. So oxidation occurs actually at the anode. So this is your anode, the positive one, right? And reduction at the electrode 2, so it is negative. This is cathode, right? Okay, now we can see the question. Which rows which rows show the direction of the movement of electrons? First of all, you have to see the movement of the electrons in the external circuit. Yes, of course, they move in the external circuit, and of the positive ions in the electrolyte. So first of all, for electrons, you need to remember they move towards the cathode. Yeah, in the external circuit, they will move towards the cathode. So from where they are moving? From 1 to 2, right? So from 1 to 2 in the these two options are right. So now direction of the movement of positive ions in the electrolyte. So positive ions will also move towards the cathode, right? So positive ions will also move towards the cathode. It means they will move towards electrode 2. So where they are moving from here to 2. So this option is the right option. That's why option A is the correct option. Question 7. Which diagram shows the direction of the movement of ions and electrons during the electrolysis of molten sodium chloride? Now we have molten sodium chloride, right? So we have to see the direction of the ions. First of all, we should know that sodium is a positive and chloride will be negative. So this one will move towards the cathode and this one will move towards the anode. Let's see, are they moving towards the anode or cathode? So sodium is moved towards the cathode. Yes, chlorine is moving towards anode. That's right. Let's see for this one. Sodium is moving towards anode. Wrong. Sodium is moving towards anode. Again, wrong. Sodium is moving towards cathode and chlorine is moving towards the anode. Yes, so they both are right, A and D. Now we have to check the movement of the electrons, right? So electron movement should be like this, from anode towards the cathode. So let's see the electron movement. Can you see these electrons? Electron arrow is downward. It should be upward, right? And then it should move from here towards the down. So this means it's wrong. Let's see here. Yes. For the anode, if you see it's moving, if you see the electrons, can you see for the electrons? Let's see what is happening here. And sodium. Okay, that's fine. And then sodium is moving towards the cathode. And here we have chlorines are moving towards the anode. And now anode, okay, the cathode. This one is wrong. Okay, here now you see, okay, sorry, this one is wrong because if you see this is cathode. So cathode, it should move towards here. So of course my mistake. Wait a minute. I just assume that it is actually, okay, this is cathode. So of course the electron should come towards the cathode, right? From the anode. Okay, yeah, from the anode, yeah, they are all upright. From the anode, it should come towards the cathode. Yes, they are coming towards down like cathode. So option A is the right option. Option A is the right option. Let's see question number 8. Molten sodium chloride is electrolyzed using inert electrodes. Okay, now we have molten sodium. So Na and Cl will be our two ions that will go to the positive and the negative. So our product will be sodium and chlorine gas. Which row shows the product formed at the cathode and anode? So cathode, what you will get, of course, sodium. So where you can see sodium, yes. So it means this is the only option that is right. So option D is the right option. At anode, we will get chlorine. Question 9. Dilute aqueous sodium chloride is electrolyzed using carbon electrodes. Now we have dilute aqueous sodium chloride. Aqueous, I already told you, whenever you will see the aqueous, so your product at the cathode will be hydrogen. Now they are asking about the anode, not about the cathode. So for the anode, the game is about dilute or concentrated. This one is what? This is dilute. So it means you will get what? Oxygen, not the chlorine, right? Not the chlorine gas, you will get the oxygen. So where is oxygen? Yes, option C is the right option. Question number 10. Electrolysis is carried out on dilute aqueous potassium bromide. Which products are formed at the anode and the cathode? So this is potassium bromide and this is dilute aqueous, right? So potassium, of course, it's a metal, right? But it is a solution, right? So in solution, I already told you, if you have an aqueous solution at the cathode, it is, if it's not copper, this is not copper, so you will get what? Hydrogen gas all the time. So can you see any hydrogen gas that has been formed at the cathode? So hydrogen, yes, this is the only option left over here as hydrogen. So what you will get, of course, option A is the right option. So if you see this option again, you will see that bromine should not be formed because it is dilute, right? The bromine should not form. Oxygen should form at the anode. But because we have no other option, so it is possible sometime for the halogens that they can also be produced at the anode. The bromine gas can be produced at the anode except instead of oxygen. Okay, sometimes they have competition, so bromine can also be produced at there. But if you have the oxygen option, you have to prefer that option if this is dilute. Okay, but we don't have the option, so we will choose A option. So that's why A option is the right option. Question 11. A dilute aqueous solution of sodium bromide is electrolyzed using inert electrodes. Which row identify the product at the cathode and at the anode? So now we are with the dilute aqueous solution of sodium bromide. Whenever you have dilute solution, you are not going to get anything from here. So cathode, you will get hydrogen, right? if it is aqueous, because of aqueous, and because of dilute, so you at the anode what you will get? You will get oxygen. So can you see oxygen and hydrogen? Okay, at cathode we are getting hydrogen, yes, right, and at anode we are getting oxygen. So C option is the right option. Question 12. Dilute aqueous potassium chloride is electrolyzed using platinum electrodes. Which row identifies the product at each electrodes? So again we have aqueous solution and that is dilute. So you are not going to get anything from potassium or chloride, right? At the cathode you are going to get hydrogen at cathode, and at anode you are going to get what? You are going to get the oxygen. So can you see hydrogen and oxygen here? At the anode, yes, it's oxygen, and at the cathode, it should be hydrogen. So option C is again the right option. Let's see question number 13. Aqueous copper sulfate is electrolyzed using graphite electrodes. Which row identifies the product and observation at each electrode during the electrolysis? So we have aqueous, right? But this is the main thing. We have copper now. And I already told you when there is a copper, then aqueous doesn't matter. For the cathode you will always get the copper. Okay, so at the cathode you are going to get copper instead of hydrogen. You are not going to get hydrogen. So if even if it's an aqueous solution, so where we can see the copper at the cathode? Yes, these are only the two option at the cathode. Now let's come towards the anode. So anode, we are going to get the oxygen. Why? Because sulfate ions, even if it is dilute or concentrated, usually you will not get the sulfate ions easily on the anode. They are not easy to oxidize. Okay, they are strong anions, so it's not easy for them to oxidize. They usually love to reduce, right? So that's why oxygen you will get the product. So oxygen will be your product at the for aqueous. So if it is aqueous solution, the oxygen will be your product at the anode. So okay, where you can see oxygen, yes, this option. So that's why this option is right. Oxygen will give you bubble of gas and electrode will turn big because turn pink. Why? Because the copper will start depositing on the cathode. So that's why option A is the right option. Question 14. Which statement about the electrolysis of copper sulfate, again we have solution using carbon electrodes, is correct? Be very careful whenever you see the carbon electrode or another electrode, because sometimes the answer will be changed for copper sulfate according to the electrode. I will tell you in the next questions, we will see that. Okay. Now electrolysis of copper sulfate is taking place. So first you have to remember, at cathode what we will get? We will get of course copper, right? At the anode what we are going to get is copper sulfate, right? So you are going to get oxygen. So now let's see what are the options. A colorless gas is produced at the anode. Yes, that's right. Oxygen is a colorless gas. So option A is the right option. A colorless gas is produced at the cathode. Wrong. Even you can see here, because it's copper, it's a metal, the color of electrolyte remain the same. Why the color of the electrolyte will remain? Copper sulfate, you know this solution has a blue color. So when these ions will start depositing at the cathode, of course your solution color will fade away. That's why this is also wrong. The mass of both electrode remain constant. That's also wrong, because anode, of course, it will remain same. Oxygen will bubble through. But cathode, the copper will start depositing on the cathode, right? So the mass of the cathode will start increasing. That's why this option is also wrong. We are only left with option A. That's why option A is the right option. Question 15. Aqueous copper sulfate, again we have, is electrolyzed using carbon electrodes. What is the product at each electrode? So product of the positive electrode. Positive is our anode, right? So of course you are going to get oxygen here. And at the negative electrode is cathode, so you are going to get copper. So copper and oxygen, yes, these are the two right options. So option C is the right option. Question 16. Aqueous copper sulfate is electrolyzed using carbon electrodes. Which statement is correct? Bubbles of hydrogen gas are formed at the anode. Okay, so again we see here copper sulfate we have. So at anode, what are we going to get? Oxygen, right? At cathode, we are going to get copper. So copper at the anode, what's happening? Oxygen. So they say hydrogen gas. Wrong. Bubble of oxygen gas are formed at the cathode. Wrong. It's at the anode. Copper is deposited at the anode. No, it's deposited at the cathode. Wrong. The blue color of the solution fades. Yes, that's right. The blue, because copper is depositing at the cathode. So for in the solution, we are less with the copper ions. So solution will be only left with the sulfate and also with the hydrogen, right? So that's why the blue color will fade, and option D is the only right option. Question 17. The diagram shows the electrolysis of the aqueous copper sulfate using inert electrodes. Which row shows the movement of electrons in the circuit? So now they have the target of our question is the movement of electrons. So electrons always move in the external circuit. That is our external circuit, right? So which options are here, A or B? So A or B can be right. Now let's see the movement of the electrons. The movement of electrons is always towards the cathode. So can you see it is towards the cathode here? Yes, at downwards, right? But here it is towards the anode. So option A is the wrong option. Only option B is the right option. Okay, I hope this is clear to you. Let's see question 18. The electrolysis of aqueous copper sulfate using inert electrodes is shown. Again, the same question. Copper sulfate, can you see that most of the questions are related to the copper sulfate? Okay. Okay. Now let's see which statement about reaction at an electrode is correct. Let's see one by one. So copper ions. Okay, let's see first. We can write for our, so we don't get confused. At cathode, what we are going to get, we will get copper, and at anode, of course, we are going to get oxygen. Copper ions gains electron at the negative electrode. That is the cathode, right? Copper ions, they will come because at cathode, they will gain the electrons. At cathode, reduction is taking place, so they will gain the electrons, yes, at the negative electrode. That's option is the right option, right? Copper ions gains electron at the positive electrode. Positive is anode, so of course copper is not coming here. Wrong option. Hydrogen ions gains electron at negative. No, hydrogen is not coming, not moving here. The hydrogen ions are not moving towards cathode. It's copper ions actually moving. Okay, hydrogen ions gain electron at the positive electrode. Of course not. Oxygen is here, so this option is also right. So we are only left with option A. So option A is the right option. Question 19. Aqueous copper sulfate is electrolyzed using copper electrodes. Okay, so now these are not the carbon electrodes. These are copper electrodes. That's why I was telling you, you have to be very careful when the question is related to copper, and also you have to see carefully the electrodes. So when there was carbon electrodes, it was obvious that at cathode you are getting copper, right? And at anode you are getting your, if it was sulfate, you will get your oxygen, right? But if you are using copper electrodes, this is only for the carbon electrodes, right? Okay, or platinum because they are inert. But for copper electrodes, remember that copper is not inert. So what will happen if you have anode and cathode? At cathode, what will happen? They both are of copper, right? So at anode, what will happen? The copper ions, it will be same. The copper ions will come here, okay? They will move towards the cathode. They will join this place, and then they will gain the electrons and will become the copper metal. Same like the carbon electrode, okay? They will become the copper metal. So they will start depositing here. But here, the anode is made up of copper. What it will do actually, it will start doing the oxidation. Anode is, and at anode oxidation takes place, right? So what will happen at anode? This anode, because it is made up of copper, it will start oxidizing itself, and you will see a loss in the mass of the anode because the copper ion, the copper metal will start changing into copper ions, and it will become the ions, and these ions will start dissolving in the electrolyte. Okay, they will become a part of the electrolyte. So that's what's happening at the anode. So when you are using copper electrodes, what are your products at cathode and anode? At anode, your product is actually the copper ions. The copper atom is changed into copper ions. So at cathode, it is same like the carbon electrodes. It will be still the copper metal will be produced at the cathode. Okay, copper metal, copper ions will change into copper metal, and you will see the deposition of the copper metals, copper metal at the cathode. So now let's see one by one which statement is correct. Oxygen gas is produced as at the positive electrode. No, that's not right now because it's not a carbon electrode. The blue color of the solution gradually fades. That's also wrong. If it is a carbon electrode, it will fade, but because the anode is now oxidizing, it's making copper ions, And so now in the solution we have copper ions. So the color will not change. It will not even increase, but it will also not change, because the copper ions in the electrolyte, they are moving towards the cathode, and we are getting more ions from the anode, right? So that's why nothing will happen, nothing will happen to the color change. Okay, so the color will remain the same. Okay, the concentration of copper ions in the solution stays the same. Yes, that's right, because the copper ions which will move towards here, we will get them back again from the anode, right? So that's why the concentration will remain the same. The mass of the negative electrode decrease. That's wrong. It's a cathode. Of course, it will increase because copper metal is depositing there. So only option C is the right option. Question 20, aqueous copper sulfate is electrolyte using copper electrode. Again, the same question. Which statement is correct? A reduction reaction occurs at the positive electrode. Positive electrode is anode. Always oxidation takes place there. So that's wrong now. The blue color of the solution becomes darker. Wrong. It will remain constant. Not darker, it will remain constant. The concentration of the copper ions in the solution decrease. That's also wrong. It will remain the same, okay, because we are getting it from the anodes. The electrolyte copper ions are moving towards the cathode, and anode copper is changing back into copper ions. Okay, the mass of the negative electrode increase. Yes, that's right, because copper metal is going to deposit at the cathode, and cathode is actually the negative electrode. So option D is the right option. Question 21, aqueous copper sulfate is electrolyte using copper electrode. Again, the same question. Now you have to find which is not correct. Oxidation reaction occurs at the positive electrode. Yes. The current is carried through the electrolyte by ions. Yes. In the electrolyte, it's always by ions, okay? The negative electrode gains the mass. Yes, that's right, because copper will deposit there. The number of copper ions in the electrolyte decrease. That's wrong. When they were decreasing, okay, they were moving towards the cathode, right? But we are getting again the copper ions from the anode, right? So the anode will provide these copper ions again, so it will remain the same. So option D is not correct. Question 22, aqueous copper sulfate is electrolyzed using copper electrodes. Again, we are using the copper electrodes. So which statement describes what happens during the electrolysis? So now copper atoms gain electrons. Okay, yes, that's right. At the cathode. That's wrong. Sorry, not gain the electrons. Yes, they gain. Okay, yeah, at the cathode, they will gain the electrons. That's right. But it's not atoms. Actually, ions will gain the electrons. Okay, so that's why this option is wrong. You don't need to read this. Electrons move in the electric external circuit. Yes, that's right. From the positive electrodes to the negative electrode. Yes, that's the right option. From anode towards the cathode, they move. Okay. So option B is the right option. You can also look for the option C and D. I already have explained what will happen. So I think it will be clear to you. Question 23. The diagram shows a circuit used to electrolyze the aqueous copper sulfate. Okay, this is the diagram now. Which arrow indicates the movement of copper ions in the electrolyte and of the electrons in the external circuit? So copper ions will always move towards where? Of course, towards the cathode. Where is our cathode? Negative charge is our cathode. So copper ions will move towards the cathode. So option 2 is the for ions. Copper ions is 2. So 2 is the right option. Okay. Now let's see for the electrons in the external circuit. So electrons direction is always towards the cathode, right? So if you see they are moving from here, yes, that's right. And they are moving towards the cathode. But here you can see they are showing that it is moving away from the cathode. That's wrong. So 3 is the right option, that is C. So option C is the correct option. Question 24. Aqueous copper sulfate can be electrolyzed using either carbon electrodes or copper electrodes. Which statement describe what happens at the positive electrode? So what will happen at the anode? We will see one by one. At anode, if we have carbon electrodes, oxygen will be produced. Okay. If we have copper electrodes, what will happen? Copper ions will be the product. Okay. Copper ions will be the product. And who will be the reactant? Of course, the copper metal. So copper metal will change into copper ions. Okay. And here we will get the oxygen ions and it will change into oxygen, right? Okay, now let's see one by one. Copper is deposited if the electrode is made from the carbon. No, oxygen. We will get the oxygen at the positive electrode. So that's wrong. Okay. If it is only deposited at the cathode. Copper is deposited if the electrode is made from the copper. That's again wrong. Copper is not deposited. Actually, it becomes ions at the anode. Oxygen gas is produced if the electrode is made from the carbon. Yes, that's right. Oxygen gas is produced. Oxygen gas is produced if the electrode is made from the copper. Wrong. It will not be produced. We will get copper ions. So option C is the right option. Question 25. Which statement about the electrolysis of aqueous copper sulfate is correct? When copper electrodes are used, okay, the solution turns from blue to colorless. That's wrong. The solution will remain the same. It will remain same. Okay, when you are using copper electrodes. When graphite electrodes are used, bubbles of gas are formed at the cathode. At the cathode, of course, there will be copper. So that statement is also wrong. When copper electrodes are used, the anodes get smaller. Yes, that's right, because the copper electrode will start oxidizing. Okay, so that's option is right. When graphite electrodes are used, the color of the solution does not change. That's wrong. The solution color will fade. Okay, so that's why option C is the only right option. Question 26. Electrolysis is carried out on concentrated aqueous potassium bromide using inert electrodes. So now what we have here, concentrated solution and aqueous potassium bromide, right? For aqueous, at cathode you will always get hydrogen, right? At anode it will be decided based on concentrated or dilute. This one is concentrated. So concentrated at anode you will get your own chloride ion. Sorry, I'm saying chloride. You will get your own anions, right? Or you can say the negative ions. So which are the negative ions in this one? Potassium bromide, of course, the bromine, right? The bromide ions. So they will change into bromine gas. So your product will now be the bromine gas at the anode. So cathode, hydrogen, yes. And at anode, you are going to get bromine. Okay, so this option A is the right option. Question 27. The diagram shows the electrolysis of concentrated aqueous sodium chloride. Now we have aqueous. Okay, what is produced at each of the electrode? If it is aqueous, of course you are going to get hydrogen at cathode. And if it is concentrated, you are going to get your own anion, that is chloride ion. So chloride will change into chlorine. The product will be now chlorine at the anode. So can you see product at the anode is chlorine? Yes, here. And then at the cathode, it should be hydrogen. So, okay. So option A is the right option. Question 28. Which substance is not produced during the electrolysis of concentrated aqueous sodium chloride? Okay, so at cathode, again, you are going to get hydrogen. At anode, what are you going to get? Chloride ions, because it is concentrated, right? So you are going to get, the product will be chlorine gas. So this is your product. Now, what you are left with in the solution? What is left? From water, you will just left with oxygen, right? Sorry, if you have water, H2O, then it will be positive ions, and then you are left with OH, right? And then we have from sodium, and we have chloride ions in the electrolyte, right? So this one is already here. This one is already here. So what we are left with? NaOH. So in the solution, we are going to get an alkaline solution, NaOH. That is sodium hydroxide. Yes, these are the three products. Now, chlorine, hydrogen, and sodium hydroxide. So this is the only product which we will not be produced. Okay, so sodium is the right option. Question 29. The diagram shows the two gases are formed when concentrated hydrochloric acid is electrolyzed using inert electrodes. So which option is right? This is concentrated and you are going to do hydrochloric acid. So at cathode, of course, if it is an aqueous solution, I already told you, you will get hydrogen, right? But at the anode, it depends on concentrated or dilute solution. This one is concentrated, so you will get your own anions. What is hydrochloric acid? HCl, right? So this is your negative ion. So chlorine will come here and become a chlorine gas. So at anode, you are going to get a chlorine gas. What is the color of chlorine gas? We already know it's a yellow-green gas. So that's why at anode, you are going to get a yellow-green gas. But at the cathode, you are going to get hydrogen, which is colorless, right? So colorless is the right option. So which option is right? Option C is the correct option. Question 30. The diagram shows the electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride using carbon electrodes. At which electrodes is hydrogen produced? So concentrated, of course, then it means concentrated HCl and concentrated sodium chloride, right? At cathode, hydrogen, of course, will be produced at the cathode always. And cathode is a negative charge, right? So you are going to get your hydrogen at the cathode if the solutions are aqueous. The both solutions are aqueous, so you are going to get at the cathode. So let's see where is our cathode. Electrode 1 is not the cathode. Electrode 2 is the cathode right here. And electrode 4 is the cathode. So you are going to get your hydrogen at the option D. Okay, option D is the right option. Question 31. Concentrated aqueous sodium chloride, again we have concentrated solution, and dilute sulfuric acid are both electrolyzed using inert electrodes. Which row identifies the products at the cathode? So I already told you, when it's an aqueous solution, it has nothing to do with the concentrated or dilute if they are asking about cathode. At cathode, you will always get hydrogen except for the copper, right? So there is no copper. This is sulfuric acid and there is sodium chloride. So you are going to get hydrogen at the cathode for both of them. So now aqueous sodium chloride will also produce hydrogen, yes, and dilute sulfuric will also produce hydrogen. So option B is the right option. Question 32. The electrolysis of the concentrated aqueous sodium chloride and molten sodium chloride is shown. What are the products at electrode 1 and 2? What is our electrode 1? It is cathode, right? What is our electrode 2? It is anode. Now we have to check one by one. What is our product? At cathode, and this is concentrated aqueous sodium chloride. So if it's aqueous, cathode will always produce hydrogen gas, right? If it is molten, of course, you will get your own anions or cations, okay? So now at anode, what will come here? We have to check for the anode. So chlorine gas will come here. So you are going to, sorry, chlorine gas will be produced here. Chloride ions will come here, right? So you are going to get a chlorine gas because oxidation will take place. So anode, you will chlorine gas will be produced. So electrode 2 chlorine, yes, and at here it's hydrogen. So option B is the right option. Question 33. Which statement about the electrolysis of concentrated copper chloride are correct? Copper chloride. Remember, now we have copper, right? So at cathode, you are not going to get, even if it is aqueous, right? Concentrated means it's aqueous. They're talking about aqueous solution. But at cathode, you are not going to get hydrogen. Now what you will get? You will get, of course, copper. Now let's come towards the anode. What you are going to get? If it's an aqueous solution of the copper sulfate, of course, you will get the oxygen. But here it is chloride ions now. What you are going to get, of course, you will get a chlorine gas. It is concentrated and it's halogen. So whenever the solution has a halogen and the solution is concentrated, you are probably going to get at the anode that halogen, okay? So at concentrated copper chloride, you are going to get chlorine as a product at the anode. So now let's see one by one which options are right. Electrons are transferred from the cathode to the copper ions. Yes, that's right, because at cathode, usually what is happening? Reduction. So whichever ion will come at the cathode, it will gain the electrons. So electrons are transferred from the cathode to the copper ions. Electrons move around the external circuit from the cathode to the anode. That's wrong. From anode to the cathode, they move. Okay, that's why cathode have electrons. Chloride ions are attracted to the anode. So chloride ions are attracted towards the anode. Yes, that's right. Hydroxide ions transfer electrons to the cathode. Of course not, because copper is deposited at the cathode. So hydroxide ions, of course, they will not come. So which option is right now? Option 1 and 3. So A option is the right option. Molten sodium chloride and concentrated aqueous sodium chloride are electrolyzed using platinum electrodes. So what are the products at the negative electrode cathode? Again, molten sodium chloride. So now we will get what? At cathode, cathode is negative. So you are going to get sodium. So where is the sodium option? Yes, here. Now it's concentrated aqueous sodium chloride. Now what you will get? You are not going to get sodium. Now you will get at cathode hydrogen always. So hydrogen is the option. So option C is the right option. Question 35. The diagram shows an electrolysis circuit at which electrode is hydrogen formed. So now we have molten sodium chloride and aqueous sodium chloride, right? So molten sodium chloride, this is positive. What will come here? Chlorine gas. Sodium will be deposited here, right? For aqueous sodium chloride, what will happen? Because they did not talk about dilute or it's concentrated, so we will assume it as a concentrated. So what will come over here? Of course, the chlorine will come at the anode, and at the cathode, what thing will come? Of course, the sodium, right? So the sodium will come at the anode. So where you are getting the, oh, sorry, not, because it's an aqueous. So at the cathode, of course, you are going to get what? Hydrogen, because it's aqueous. So aqueous always at the cathode, you are going to get hydrogen. So where the hydrogen option is? Electrode only at the B. So B option is the right option. Question 36. Which substance produce hydrogen and bromine when electrolyzed? So already it's simple. Hydrogen. If it's hydrogen, you need to remember that the solution is actually aqueous, right? That's why you will get hydrogen at the cathode. Now, if you are getting oxygen, then it means it's a dilute solution, right? But they are saying bromine, so it means it is, the solution is actually concentrated, right? So the solution is concentrated aqueous. So let's see where we can see concentrated aqueous. Concentrated aqueous, molten, of course, wrong, and dilute is also wrong. Now let's see one by one these two options. When the solution is aqueous at cathode, you always get hydrogen. You remember that one, right? But I told you there is an exception case. If you have copper solution, you will never get hydrogen. You will get copper at the cathode. So here they are already telling you it's a copper bromide. So it means it's wrong, right? This option cannot be correct because we will not get hydrogen. We will get copper and bromine. So that's the only leftover option, that is option B. So because it's aqueous, so you will get hydrogen at the cathode, and because it's concentrated, so you are going to get bromine at the anode. So option B is the right option. Question 37. Which statement about the products of electrolysis using inert electrodes are correct? So this is a general statement. We will see one by one. When molten lead bromide is electrolyzed, bromine is formed at the cathode. Molten lead bromide. So which one? This is cathode. So positive ions will come here. Of course, lead is a metal, so lead will come here. Lead will move towards the cathode. Bromine is not the option, so that's right. That's wrong. When dilute sulfuric acid is electrolyzed, oxygen is formed at the anode. Yes, that's right. Why? Because it is dilute, right? So dilute, of course, you are going to get oxygen at the anode. When concentrated aqueous sodium chloride is electrolyzed, sodium is formed at the cathode. At the cathode, you are never going to get sodium if the solution is aqueous. It will always be hydrogen, right? So this option is also wrong. When concentrated hydrochloric acid is electrolyzed, okay, now this is concentrated. Chlorine is formed at the anode. Yes, that's right, because this is concentrated. So anode game depends on the concentrated or dilute solution, right? So if it is concentrated, you will get your own anion of the electrolyte. So the anion is actually chloride ions. So chloride ions will move here and you will get a chlorine gas. So this option is also right. So 2 and 4 option is correct. That is option C. Question 38. In separate experiments, electricity was passed through the concentrated aqueous sodium chloride and molten lead bromide. What would happen in both experiment? So anything that will happen in both experiment, we have to look for the anode and cathode. So anode and cathode, what will happen? For aqueous, always water, hydrogen, right, at the cathode. At anode depends on concentrated. So if it's concentrated, you are going to get your own anions that are chloride ions, so they will change into chlorine gas. Okay, let's see for molten lead bromide at anode, at cathode it will remain the same, nothing will change. Lead will come for the, okay, Pb, it will come here at the cathode, and whereas bromine you are going to get at the anode, right? Bromine gas. So now let's see one by one. A halogen would be formed at the anode. At anode, these both are halogen. They belong to group 7, and all elements of the group 7 are halogen. So that's right. A metal would be formed at the cathode. Yes, a metal is formed at the cathode, but not on both the experiment, only in one. So that's wrong. Hydrogen would be formed at the anode. Yes, hydrogen. No, hydrogen is forming at the cathode. That's wrong. Hydrogen would be formed at the cathode. Yes, that's right. It formed at the cathode, but not in both experiments, right? Only in one experiment. So that's also wrong. So only option A is the right option. Question 39. An electrolysis experiment is done using carbon electrodes. Hydrogen and oxygen are formed at the electrodes. What is the electrolyte? Simple. If hydrogen is produced, it means it's aqueous, right? If oxygen is produced, it means the solution is dilute. So you have to look for the dilute solution. So this is the only dilute solution here. Dilute aqueous sodium chloride, right? So this option is the right option. Option C. 40. Two different substances are electrolyzed using inert electrodes in two experiments. Hydrogen is produced in both the experiments. Okay, so hydrogen means the solution was aqueous, right? Which row identifies the two substances and the electrodes at which the hydrogen is produced? First of all, you should know hydrogen always produced at the cathode, right? So at the cathode, let's see. Where is the option cathode? Yes, that's right. Now we will see one by one. Substance 2, aqueous sodium chloride. Yes, that's right. Molten sodium, no. We need both the aqueous one. Now, concentrated hydrochloric acid. Yes, that's aqueous, right? It doesn't matter it's concentrated or dilute. And dilute sulfuric acid. Yes, that's right. Because concentrated and dilute only matters for the anode, not for the cathode, right? So option D is the right option. Question 41. The diagram shows the electrolysis of aqueous solution of X using inert electrodes. Hydrogen is produced at the cathode and chlorine is produced at the anode. What is X? Hydrogen is produced. It means it's aqueous, right? This is an aqueous solution. It's not a molten solution or molten ionic compound. It's an aqueous, okay? First thing is that. Second, chlorine is produced. No oxygen is produced. It means it is a concentrated solution, right? Concentrated and also aqueous. Let's see where we can find concentrated aqueous. So these are the two where we can find concentrated and aqueous. But let's see now which option can be right. It's copper. So copper cannot be right because if you are getting a hydrogen, then copper should not be there. Okay, if copper is there, you will not get hydrogen at the cathode. You will get what? You will get copper at the cathode. So that's why only we are left with option B, that is right. Question 42. Which row correctly shows the cathode and anode products from the electrolysis of the named electrolyte? Okay, now let's see one by one. Whenever you see copper, of course, at the cathode you are going to get copper. That's the right option. Let's see for the molten lead bromide. First of all, we'll see the cathode. Lead, of course, is a metal, so it will move towards the cathode, and it's a molten, right? So that option is also right. Dilute sodium bromide solution. Solution, you will always get hydrogen. That's right. Copper sulfate solution. Again, we have copper. So even if it's solution copper, you will never get hydrogen. You will only get copper, right? So this option is wrong. Now we are left with three options. Let's see at anode. Okay, we have copper sulfate solution, but we are using copper electrodes, right? So if you are using copper electrodes, the anode product will not be oxygen because anode will start oxidizing itself and the product will be copper ions. Okay, copper atom will start change into copper ions. Molten lead bromide. So of course it's a bromide. So bromine will go at the anode and you will get a bromine, right? So this option is right. Dilute sodium bromide solution. So you are going to get a sodium dilute sodium bromide solution. Usually you will get what now? What you are going to get? You are going to get, of course, oxygen here, right? but there is a chance to get, okay, so oxygen is the, because this is dilute, so there is also a chance to get a bromine, but of course when there is oxygen, that is the best option you will have for dilute, right? Because in dilute solutions you are always going to get oxygen at the anode, except for the case sometime it's bromine. If there is a solution, a bromine solution, then you can also get bromine, but this option is also right? So option 2 and 3 are the only right option, that is C. So C is the correct option. Question 43. The apparatus used for the electrolysis is shown over here. Which statement is correct? Okay. Copper forms at the anode in some electrolysis reactions. Yes, copper is formed in some electrolysis reaction, but copper is positive, so it will be formed at the cathode. That's wrong now. Okay. Hydrogen forms at the cathode in some electrolysis reaction. Yes, that's right. Hydrogen, usually in the aqueous solution, you will get the hydrogen at the cathode. Oxygen forms at the anode. So that option is also wrong. Sodium forms at the cathode, because sodium is metal, so it should be formed at the cathode, so that's also wrong. So we are only left with option B. So option B is the right option. Question 44. Universal indicator solution is added to a neutral solution of concentrated aqueous sodium chloride. Now what is that? Aqueous sodium chloride. Okay, and this is concentrated. The solution which contains hydrogen, sodium chloride and hydroxide ions is electrolyzed. The product at the cathode is hydrogen gas. Yes, we know that because it's aqueous solution. And at the anode, it's a chlorine gas. Yes, because it's a concentrated. So what we are left with, this one is done, this one is done. So we are left with Na and OH. So we are getting to go in the electrolyte, we will have NaOH, right? What happens to the color of the indicator in the solution during electrolysis? So if you added a universal indicator solution, and in electrolyte we have now NaOH is a strong alkali, right? It's a base. So usually what will be the color change? The color change for the alkalis is usually blue. The final color is usually blue. Can you see the blue? It's green to blue, blue to red, blue to green, green to red. So green to blue. Blue should be the final one. So option C is the right option. Question 45. What is the ionic half equation for the reaction that occurs at the cathode when molten lead bromide is electrolyzed? So now we will see all the ionic half equations related to the electrolysis. So now we already know what will we are going to get at the cathode. First of all, you have to identify that thing. What is your electrolyte? Molten lead bromide. So this is cathode. The positive ions will come here. It means lead will come here, right? So lead ions will come here, and lead is 2, right? So it means Pb2 plus. These ions will come at the cathode and it will change into lead atom. Where you can see this one? Yes. Okay, you get a lead atom. And because at cathode reduction occurs, so what does it mean? Reduction means that ions will gain the electrons, and gaining electrons we always write in the reacting, because they are gaining, right? And the end they will give you a product that will be a metal. So you can, in product you cannot write here, you cannot write this one, it will be wrong. Okay, you cannot write like this Pb2 plus and then it becomes Pb plus 2e negative. That's wrong, because this negative will cancel this positive and then you will be just left with Pb here. That's why the two negatives should be, these two electrons should come here, not here. Okay, so that's wrong, you should not write here. So option A is the right option. Now let's see option 46. Which reaction takes place at the cathode during the electrolysis of molten nickel chloride? Now this is molten nickel chloride and you have to check at the cathode. At the cathode again you will get a metal. So nickel has a 2 oxidation state, so it means Ni2 plus. And then of course at cathode reduction will take place. So it is 2 plus, so it will gain 2 electrons and it will become a metal. So can you see this equation here? Yes, that's option D. Question 47. Now we came with the aqueous copper sulfate is electrolyzed using copper electrodes. Now the electrodes are also copper, right? Right. What is the half equation for the reaction at the cathode? So if it's aqueous solution, you will always get hydrogen, right? But this is now copper sulfate. So in the presence of copper sulfate, you can never get hydrogen. You will always get copper at the cathode. So copper ions will come here, right? And then they will gain the electrons, because at cathode reduction is taking place. So electrons should come in the reactants. These two are the reactants, and what will be your product? It's a copper metal. So can you see this equation anywhere? Yes, right? So D option is the right option. Question 48, an aqueous solution of copper sulfate was electrolyzed using copper electrodes. Which equation for the reaction at the anode is correct? Now again we have copper electrodes. So what will happen at the anode? I already told you oxidation will take place, and this copper, because this copper start oxidizing. So what is this copper actually? Now this copper is actually a metal, right? So copper is actually, this electrode is a metal. So this metal will do what? It will start oxidizing. And now when it oxidizes, it will change into copper ions. And copper ions, so where are the electrons? It will come here in the product because oxidation is taking place. So in oxidation, usually your electrons will come in the product. You have to write the electrons in the product, not in the reactant. Okay, this is oxidation process. That's why these two will cancel each other and you will get the copper metal, right? So that's why you cannot write with the metal these two electrons. So that's why this option is the right option. Can you see here this option? So copper, yes. So option A is the right option. Question 49. Which row describes the reaction during the electrolysis of dilute aqueous sodium bromide? Okay, at anode and cathode both. So it is aqueous for, of course, and this is sodium chloride. So aqueous, you are going to get hydrogen at the cathode. Can you see hydrogen at the cathode? Yes, these two are the reactions. Now let's see for the dilute. Okay, for dilute, you are going to get oxygen, right? So where you are getting oxygen, here also, here also. Now let's see which equation is actually right? So at cathode, reduction takes place. Remember that reduction when takes place, I told you that electrons we have to write in the reactants. Here, let's see this one. This is hydrogen gas. First of all, that's wrong. Why hydrogen gas is at the cathode in the reactants? What will come at which ions will come at the cathode? Of course, hydrogen ions will come. Hydrogen ions will come at the cathode here and they will gain the electrons and become hydrogen. Clear? Hydrogen gas. So this is actually your product. Your product should be here, H2. Gas is the product. So this option is the right option. This option is the wrong. Same is for the oxygen. Now you can see how oxygen is produced because we have hydroxide ions that will come at the anode, right? The hydroxide ions when move towards the anode, these are your hydroxide ions. You will get water and oxygen and then electrons because this oxidation is taking place. And I already told you in oxidation, the electrons are always in the product, right? Not in the reactant. So in the reactant, only in the reduction, you will see it in the reactant. So you need to remember how you need to remember that if you in exam you get confused that how that where should I put my electrons in the reaction. So you can remember the trick reduction. Okay, reduction is equal to reactant because these words are same, right? So reactant and reduction. So if there is reduction taking place, your electrons should be in the reactant, not in the product. Okay, so now in anode it will be the opposite. I hope this is clear to you. You see, in the reactants, we have electrons because it is reduction. At cathode, the reduction is taking place. So that's why option D is the only right option. Question 50. During the electrolysis of dilute sulfuric acid, hydrogen is collected at the cathode. Which ionic half equation for this reaction? Again, for the hydrogen, simple hydrogen gas will be produced. So we have to see where hydrogen gas is producing in the product. This is the only option, right? Where hydrogen gas is produced. And here it is also hydrogen gas is produced. But because this is reduction, right? In reduction, your electrons should be in the reactants, but they are in the product. So it means it's wrong. This one is the right option. So that's why option C is correct. Question 51. Dilute sulfuric acid is electrolyzed using inert electrodes. What are the ionic half equation for the reaction that take place at each electrode? So now what is our product? Dilute sulfuric acid. First, it is aqueous. So at cathode, you are going to get what? You are going to get hydrogen. It is dilute. Now at anode, you are also going to get oxygen. So let's see now the reaction. Your product should be oxygen and your product should be hydrogen at cathode. So this is negative electrode, cathode, yes. Let's see where we can see hydrogen. These two options. Okay, that's right. Now let's see for the anode where we can see oxygen. Yes, here you can see oxygen, but here you can see water. That's wrong. Okay, oxygen is the only right option. So option C is the correct option. So once you already know that, okay, if the both things are same, then you have to look for the electrons or whatever I have told you. But if you already know the hints that, okay, hydrogen is the gas, you don't need to look for the whole now equation. Okay, it's already clear. So that's why option C is the right option. Question 52. Dilute aqueous sodium chloride is electrolyzed using platinum electrodes. What is the reaction at cathode? It's aqueous. So cathode has nothing to do with dilute or concentrated. It's aqueous will decide that you are going to get hydrogen. So your product should be hydrogen, right? So where you can see hydrogen? Here. No, no, no. So option A is the right option. What are the ionic half equation for the electrode reactions during the electrolysis of concentrated aqueous sodium chloride? So again, we have aqueous sodium chloride and you have to tell the electrodes reaction both. So first it's aqueous. So at cathode, you are going to get hydrogen for sure. It's concentrated. So now you are going to get your own anions that is in the electrolyte. So where is your anion? It's of course the negative charge chloride. So at anode you are going to get what product? That is a chlorine gas. Okay, because this is concentrated. If it was dilute you will get oxygen, but it is concentrated, so you will get your own anions that is from the electrolyte chloride. Okay. So now let's see where we can find hydrogen and chlorine. So cathode, hydrogen, where you can find? Yes, this one here, right? There is no hydrogen gas here. Can you see hydrogen? It's not a hydrogen gas here in the product. So these all options are wrong. So now don't look at the other options. You can see here you are getting a chlorine gas, right, at the anode. So option B is the right option. Question 54. Concentrated aqueous sodium chloride is electrolyzed. Which equation represent the reaction at the cathode? At the cathode and is aqueous, always hydrogen. So where you can see the hydrogen gas? Yes. Here you can see the hydrogen gas. So option C is the right option. Okay. Concentrated aqueous copper sulfate is electrolyzed using copper electrodes. Which ionic half equation describe the reaction taking place at the cathode? Now these are the copper electrodes, but cathode has nothing to do with the copper electrodes. It's only with the anode if you have the copper electrodes, okay? So, but this is copper sulfate, aqueous copper. So copper means if copper is there, hydrogen will never come here, right? It will never, the hydrogen ions will not move towards cathode. It's copper will move towards the cathode. So now what will be your product? Your product will be the copper metal. Can you see the copper metal as a product? Yes. It's only here we can see the copper as a metal. Here it's ions. So ions is not the right option. We are getting a copper metal as the product because ions will move towards towards the cathode. They will gain 2 electrons and it will become a metal, right? So option D is the right option. Question 56. Electrolytes can be broken down by electrolysis. Which rows are correct for each electrolyte? So, for each electrolyte, which rows are correct? So, let's see one by one because these are the reactions, so it will take more time. So, first we will see the product at the anode. Dilute aqueous potassium chloride. Aqueous, and if it is dilute, of course, you are going to get oxygen. Concentrated hydrochloric acid. If it's concentrated, oxygen will not be the product. Of course, your product will be your anion, that is Cl, right? So this is right. Molten aluminium oxide. At the anode, you are going to get your own anion because, and that is oxygen, right? So oxygen should be, no, it's not here. Concentrated aqueous sodium bromide. So what you need to get here? It is concentrated, right? So at anode you are going to get your own anion, that is bromide. So bromide will change into bromine gas. So these three options are right. Now let's see one by one for the reaction at the cathode. Because it's aqueous, right? So aqueous will always give you hydrogen at the cathode. Yes, you are going to get hydrogen at the cathode. That's right. Concentrated hydrochloric acid. Again, it's aqueous, right? So you are going to get hydrogen at the cathode. Now let's see. Concentrated aqueous sodium bromide. It's aqueous. You are going to get hydrogen again. No, hydrogen is not there. So only 1 and 2 is right. That is option A. Question 57. Electrolytes can be broken down by electrolysis. Which rows are correct for each electrolyte? Again, the question is same, only this one is different. There they have used, if you see, They use, I think, potassium chloride, and it is now sodium chloride, but all other things are same here if you see. So that's why these options are the same. Option 1 and 2 are right. You can check it again and you will see the option A is the correct option. Question 58, concentrated aqueous. Now, concentrated aqueous magnesium bromide is electrolyzed using carbon electrodes. Which equation represent the reaction occurring at each electrode? So, it's aqueous. Of course, you are going to at the cathode, that is cathode, right? You are going to get hydrogen. Where you can see hydrogen? Yes, this option. So, you are not, no other option has hydrogen. So, it means even you don't have to look over here. The option, this option, of course, is right option. But because this is concentrated, you can check once again. Concentrated will always give your own anion at the anode, that is bromine, right? So you are going the bromine gas. You are going to get the bromine gas, right? It's here, bromine. So that's why, okay, option A is the right option. Question 59. Aqueous copper sulfate is electrolyzed using copper electrodes. What is the ionic half equation for the reaction at the cathode? Again, see, at the cathode, you are going to get copper ions, right? So copper ions will go there and then they will gain the electrons and it will become a copper metal. So this will be your reaction. Where you can see the copper, yes, this is the only here we are going to get the copper metal. Here it's the ions that's wrong because ions will move towards the cathode and they will reduce there and become the copper metal. So that's why option B is only the right option. Question 60. In experiment 1, aqueous copper sulfate is electrolyzed using graphite electrodes. In experiment 2, aqueous copper sulfate is electrolyzed using copper electrodes. So which statement identifies a half equation for the reaction at one of the electrodes? Now in experiment 1, half equation for anode. First of all, let's see what is happening at the experiment 1. It's aqueous copper sulfate and we are using the graphite electrodes. So what we are going to get at anode? Of course, not sulfate ions. We are going to get oxygen. At cathode, we are going to get copper, right? For this one. For this one, at anode, cathode, of course, it will be same. We will get the copper metal. Copper ions will come and copper ions will move towards cathode and it will change into copper metal, right? But anode, what is going to happen if you are using a copper electrode? The same copper electrode, the copper anode itself will oxidize and it will change into copper ions, right? So this will be your product at the anode, and at the cathode your product will be the metal. At anode the product will be the ions. Let's see now one by one. Experiment 1, the half equation for the anode reaction is this. Anode. Of course, the hydroxide ions will come at the anode. That's right. And they will change into water, oxygen, and electrons. So that's option is the right option, right? In experiment 1, the half equation for the cathode reaction is this. Wrong. The copper should be the reaction. Should get copper. Experiment 2, the half equation for the anode reaction is this one. Wrong. Copper ions will not move towards anode. The copper metal will actually oxidize and it will change into copper ions. Don't get confused. This reaction is actually taking place at the cathode. So that's wrong. In experiment 2, the half equation for the cathode reaction is this. That's wrong. It's actually this reaction is taking place at the cathode. So only option A is the right option. Question 61. Aluminium is extracted by electrolysis as shown here. So which row shows the ionic half equation at the cathode and anode? So aluminium is actually extracted through electrolysis, and which is our electrolyte? It's already given here. We are using molten aluminium here, right? So molten, actually we are using Al2O3. So of course at the anode, the negative ions will move towards the anode, and the cathode, the positive ions will move towards the cathode, that is aluminium. And aluminium has an oxidation state of 3. Okay, so when it will come, it will move towards the cathode, what will happen? The reduction will take place, right? And reduction means electrons will be in the reactant. So this is our reactant, right? And it will change to aluminium metal. That's what they are asking for cathode. So can you see aluminium? Yes, aluminium ions are coming. You see, they are moving towards the cathode. That's right. But now we have to see our equation. In the reactants, we should have the what? We should have the electrons. electrons, okay, and it will change into metal. So these two options are the right option. Now let's see for the anode. At anode, oxygen ions will come at the anode, right? Oxygen ions will come at the anode, they will move towards there, and what will happen? Okay, so now oxygen ions, when moved towards the anode, what will happen? It will change into oxygen gas, and also oxidation is taking place at the anode. So what will be your, where your electrons will be? Of course in the product, okay, because in the reduction they are in the reactant, so in oxidation they will be in the product, right? So how many electrons will be here? 4. So can you see where is this option? Yes, here. Okay, so I hope this is clear to you. So option C is the right option. Question 62. Aluminium is manufactured from aluminium oxide by electrolysis. Which row shows the ionic half equation at each electrode and describe the role of cryolite in the process? First of all, cryolite, catalyst or solvent for. So remember that cryolite is never used as a catalyst. Actually, it is used to dissolve the aluminium oxide so that the aluminium oxide temperature is a little bit reduced. So we can use it for electrolysis. Okay, so that's why aluminium oxide, so for dissolving aluminium oxide, we use cryolite. So these two options are the right option. Now we have to choose what are the reactions taking place. So at the anode, at the cathode, you need to remember which reaction is actually taking place at the cathode. First, we will see aluminium ions will move towards cathode, right? So aluminium ions, can you see where aluminium ions are moving? Here in this one, right? So this option is the only right option. So you don't need to look at the anode. You already have now find that aluminium ions are at the cathode here. So option C is the right option. Question 63. Aluminium metal is extracted from aluminium oxide by electrolysis, ionic half equation that occurs and at the name electrode. Okay. So at anode, of course, what will happen? The oxide ions will come here. Okay, they will move towards the anode. So of course, this is right. At anode, aluminium ions, of course, will not move. They are positive. They will not move towards the anode. So at cathode, of course, oxide ions will not move towards cathode. Or aluminium ions will move towards the cathode. So any option can be right now out of these. We have to see the balancing of the equation. Aluminium ions, these are 3, right? 3 have a 3 positive charge, and then we have 3 electrons, right? They will cancel each other and we will get an aluminium metal. So option D is the right option. Here, if you see, everything is right, but this is not balanced. 2 electrons and we have 2 oxide ions. So total there should be 4 electrons. So that's why it's wrong, and option D is the right option. Question 64. Which apparatus is used now? This is all about electroplating. So before I do this question, I will tell you a quick introduction about electroplating. Electroplating is actually in which we use the coating of other metal on any object, right? So whenever you want to do electroplating, you have to choose, it's the same process like electrolysis. So you will have a cathode and anode. Okay, so the object on which you need the coating, it should be on at the cathode. Okay, for example, I have a spoon and I want to coat it with the copper, so my spoon should be at the cathode. Okay, and my anode should be made up of copper because I want to do the copper electroplating on the spoon, right? So spoon can be made up of iron or whatever. So that's how you do. Okay, what about now electrolyte? What should be your electrolyte? The compound or the solution that you will use in the solution, it should always be the solution of the anode, your anode metal, whichever you are using. For example, I'm using a copper, so I should use my electrolyte copper sulfate, not this one. If it is iron, I should not use iron sulfate. Okay, remember that whichever coating you want to use, the coating that you want to use, it should be the one actually that you have to use as an electrolyte. It's solution you have to use as an electrolyte. It's salt or maybe it's some solution. Okay, so now let's start these question. Which apparatus is used to plate a nickel object with silver? So we have to plate the nickel, right? So nickel should be on the cathode, and silver, we want to do the coating with silver, so silver should be at the anode, right? Ag. So now let's see, this nickel is at the cathode. Is that right? Yes, it's right. Nickel should be at the cathode and silver is at the anode. Silver should be at the anode. That's wrong. Silver should be at the anode. That's right. Silver should be at the anode. That's wrong. So now we are left with A and C option. Now let's see electrolyte. Electrolyte, I already told you, the anode will be the electrolyte, the solution of the anode. So what is at the anode? Silver. Of course, we want to do the electroplating with the silver. So solution should be of silver. This is silver nitrate solution. Yes, that's right. Here it is nickel nitrate. So that's wrong. Okay. So that's why option A is the right option. Let's see question 65. Which apparatus could be used to electroplate iron nail with copper? So now iron should be at the cathode. What we should have? Iron, right? So and at the anode we should have copper. Let's see. So this is cathode, this is anode, right? So anode have what? Sorry, anode should have copper sheet, right? So that's right. Anode should have copper. That's wrong. Anode should have copper. Yes, that's right. And anode should have copper, but this is cathode, so this is also wrong. So A and C can be right. Now let's see what about the solution. So which solution we have to use? Of course, the copper solution we have to use. So copper sulfate. Yes, that's right. Here we are using iron sulfate. So that's wrong, right? So this option is wrong, sorry. So let's see. Okay. So we are only left with option A. So option A is the right option. Question 66. Iron can be electroplated with zinc to make it resistant to corrosion. So you want to electroplate iron with what? Zinc. So zinc should be at the anode, right? And it should be at the cathode. So which row about the electroplating iron with the zinc is right? So zinc should be at the anode. Yes. And at iron should be at the cathode. Yes, they are right. So now we have to use which solution, which electrolyte? Of course, zinc electrolyte. So zinc nitrate is the right option. Option D is the correct option. Question 67. An object is electroplated with silver using an aqueous silver salt. Okay, they already have told you which row is correct. So if it is electroplated with silver, so of course our anode should be made up of silver, right? So the object to be electroplated is, so the object which we want to electroplate, it should be at the cathode, right? So where we can see, yes, cathode. And the other electrode that is made from, now that is anode, right? So anode should be made from what? From the silver, right? We have to use silver as an anode. So that's why option D is the right option. Question 68. Winston Churchill, a British Prime Minister, had his false teeth electroplated with the gold. The teeth were coated with a thin layer of the carbon and were then placed in the apparatus shown here. Okay. So which row is correct now? Terminal X. This is your terminal X and this is your terminal Y. So we don't know which one is cathode, which one is anode. But this will decide now. Gold, because it is electroplated with gold, so it means gold should be at the anode. So Y is actually your anode, right? And X is your, because your teeth is there, so the cathode will come here. Okay, so the cathode is this option. So now the terminal X is actually negative. Yes, because it's cathode, right? So terminal X is negative. The carbon powder could be, so they have, you see, the teeth were coated with a thin layer of the carbon. So the carbon powder should be diamond or graphite. Of course, it should be graphite because graphite is a good conductor of electricity. So it can be graphite. So that's why option B is the right option. Question 69. A metal object is electroplated with copper. One electrode is the metal object and the other electrode is the copper. So with copper, it means anode. Okay, and the metal object is at the cathode. The electrolyte is the aqueous copper sulfate. Okay, right? Which row shows the ionic half equation for the reaction at the anode and the observation of the electrolyte? So at the anode, what will happen? Of course, the electro is made up of the copper, right? So what will happen actually? Now the electrolyte has a solution copper sulfate. Okay, so the copper sulfate, the copper ions will do what? The copper ions, of course, from the electrolyte solution, they will change into what? Of course, the copper, if you see, the copper will be 2 plus into 2. The copper will become, sorry, the copper will be the ions now here, okay, the copper ions, and then we will have sulfate ions in the solution. That's right. So now what is happening at the anode actually? We already know the copper, of course, it will start oxidizing itself, because this anode will start oxidizing itself and it will change into ions. So what is happening at the anode actually? The anode is made up of copper metal, right? So copper metal will start changing into copper ions, right? So this will be the equation at the anode. You cannot write like this. This is wrong, because this happens usually at the cathode, not at the anode. This is reduction. Oxidation takes place at the anode and the copper metal will change into copper ions. So can you see which option is right? Yes, these two options are right. So now what about the electrolyte? What about the color change? The color will change or not? That is the question. The color will not change, okay? The color will not change. Why? Because the ions are, you see, the anode, it's releasing the ions, right? So when these ions will dissolve in the electrolyte, the color can become darker, but of course it will not be darker. Why? Because the electrolyte's copper ions are actually moving towards the cathode and they will deposit on the cathode, and this cathode is actually our metal object, right? So they will deposit here and they will become metal here. So these ions are now missing, but we are getting again it from the anode. So the color never changes. Whenever you are using a copper electrodes, the color of the solution never changes. The blue color of the copper sulfate never changes if you are using the copper electrodes. We already have discussed this one. So the blue color does not change. Question 70, the diagram shows a method used to copper plate a pan. So this is our pan and we want to copper plate it. So which equation represents the reaction at the cathode? So what will happen at the cathode? Of course, the copper ions will move towards the cathode now. At cathode, reduction takes place. Reduction means the electrons will be in the reactants. So copper ions will come here, okay, they will move towards the cathode, and then electrons will be in the reactant. And what will be your product? It will be a metal. So can you see this one? Yes. So option A is the only right option here. Question 71. Concentrated aqueous copper chloride is electrolyzed using copper electrode as shown here. What happens to the mass of each electrode during this process? So this is concentrated aqueous copper chloride, right? So when it's aqueous and we have copper, of course, at cathode you are going to get copper, right? So at cathode you will get the copper, but at anode you usually, if it's copper sulfate, you are going to get oxygen, right? Oxygen if there are carbon electrodes, right? And you are going to get, if it is concentrated, you are going to get chlorine gas at the carbon, if the electrodes are carbon, right? But now the question is they are using the copper electrodes. So whenever we have copper electrodes at anode, you are going to get nothing except for copper ions. This will be your product. Okay. So what will be your reactant? Your reactant will be copper metal and it will oxidize to give you copper ions and electrons. Clear? And at cathode, copper ions will move from the electrolyte solutions towards the cathode, right? And they will gain the electrons and will become a copper metal. Okay, so now this is your cathode. The copper metal is going to deposit here. So the mass will increase. Okay, but at anode, what is happening? This is the copper anode, but it is forming the ions now, right? And these ions are going to dissolve in the electrolyte solution. Okay, so what's going to happen now? This copper is slowly, the metal is changing into ions, so the mass will start going to decrease, right? Because this one, this actually electrode is getting oxidized, it is getting dissolved in the solution. So that's why the mass of the anode will decrease. Clear? So positive decrease, yes. So negative, it will increase. So option B is the right option. Question 72. The reactivity series for a number of different metals is shown. The diagram shows the different metal strip dipped into an electrolyte. These questions were the question that usually come from 2012 to 2019, but now after 2019 I did not see any question in the exam for related to like these type of questions, okay? But they can still be, we can still get these type of question in the exam because they are related to chapter number 14, metals reactivity. So it is possible that we can get them in the exam, and these are not difficult. I will just give you a quick brief introduction of this question, and then it will be easy for you to solve. So actually they are asking you about the highest voltage. Okay, the question is related to which metal strips will produce the highest voltage. Remember that when the difference between the reactivity is more, difference in reactivity is greater, reactivity is more. Okay, so what will happen? The voltage will be higher. That's the that's the only hint for this question. Okay, so it's simple. So if you choose the most reactive and the least reactive, then you will get the highest voltage. That's simple. So if you have magnesium, if I choose magnesium, yes, and then I should, okay, magnesium is here, and then I should the most difference, the difference should be more. Platinum, is there any option platinum? Yes, so it means this is the one that has the highest voltage. It's simple. So B option is the right one. Now let's see in the next question. The diagram show a simple cell. This one is the I have taken this picture from the chapter 14. This will not be given in exam, but you need to remember the reactivity. Okay. So which metal P produce the smallest voltage? Now we have to look for the smallest voltage. So it means the difference should be less. So if you are using a copper, so then you have to choose the metal that is near to the copper in the reactivity series, and that is actually the iron. Magnesium is too far from the copper. If you see here, iron is near, right? So the distance is a little. So that's why iron is the right option. Okay, B option is the correct. 74. A student set up a number of simple cells by putting strips of two different metals into dilute sulfuric acid. Which cell produced the highest voltage? Again, the question is related to highest voltage, so the difference should be more. Copper, yes, copper has the least reactivity. So you have to choose the one that has the most one. So magnesium. So the difference will be more. So that's why option A is the right option. Question again the same. The electrical energy of two voltage of two simple cells are measured. Now you have to see one by one. The voltage of cell 1 is greater than cell 2. Cell 1 is magnesium and zinc, and this one is magnesium and copper. Of course, the distance between magnesium and copper, if you see in the reactivity series, it's more. Okay, so the voltage of this cell 2 is more. So this statement is wrong. The zinc is more reactive than copper. Zinc is more reactive than copper. Yes, that's right. Magnesium is oxidized in both the cells. Of course, magnesium is highly reactive, right? So, highly reactive metals are the metals that oxidize very quickly because metals love oxidation. They love to lose electrons, right? Oxidation is losing of electrons. So, if any metal that is more reactive, it means it will lose electrons quickly. So magnesium is going to oxidize in both the cells first. Because copper is less reactive, zinc is less reactive than magnesium. So of course this is right. Magnesium atom loses electron to form magnesium ions. Yes, that's right. It loses the electrons to form magnesium ions because it's oxidized, right? So all the statements are correct. That's wrong. Only statement 1 and 3 are correct. 1 is wrong, 3 is right. So that's also wrong. Statement 2 is correct and explains statement 1. That's wrong. Okay, so because statement 1 is not wrong, so is not right, so how we can say that it's explaining? Statement 4 is correct and explains statement 3. Yes, this option can be right. Why? Because statement 4 is correct, right? It loses electrons to form magnesium ions, and it is explaining the statement 3. That's why losing electron is easily, so losing electron means oxidation. So that's why option D is the right option. Question 76. Which simple cell produce the most electrical energy? Again, the same question. It's related to the voltage. So you have to see the difference that is more. Magnesium, zinc, yes, the difference is there. Iron, zinc, no more difference. Iron, copper, less distance. Magnesium, copper, of course, the highest distance. So option C is the right option. Question 77. Which metal combination produce the highest voltage reading in the cell shown? Again, if you see, can you see magnesium and copper? Yes, option D is the right option. Question 78. The diagram shows a simple cell. Which two metal produce the highest reading on the voltmeter? Again, magnesium and copper, right? They have the longest distance, so magnesium and copper is the right option. The diagram shows two different metal strips dipped into an electrolyte. The which pair of the metal produce the highest voltage? Again, the same question, copper and magnesium. Okay, option B is right. The diagram shows a simple cell. Which pair of the metal produce the largest voltage? Again, magnesium and copper. See, the same answer is there, but actually they have changed the question in different style, but the answers are same. Okay, so that's why magnesium and copper is the right option. Again, see, the diagram shows a simple cell. Which statement about the process occurring when the cell is in operation is correct? Okay, so now this is zinc electrode, this is copper electrode. So now we will see one by one which process is right. Copper ions are formed in the solution. Okay, so copper ions are formed in the solution because this copper electrode, who will, okay, is this right or not? Copper can form the ions, but who is more reactive? Of course, zinc is more reactive. So zinc is going to oxidize first. So it will make the zinc will make the zinc ions, not the copper. So zinc will first going to make the zinc ions. So this option is not right. Electrons travel through the solution. Wrong. Only ions usually travel through the solution. Electrons move here in the external circuit. The reaction zinc occurs. Yes, zinc is a metal. Yes, it will oxidize first, right? Because it's more reactive. So zinc will change into zinc ions and electrons, right? Zinc ion and electron. It will release the electrons. So that option is the right option. The zinc electrode increase in mass. That's wrong. It will not increase in mass because it's actually losing the electrons and it is becoming an ion. Now this metal is changing into ions. So metal is going to get oxidized. It is going to dissolve in the solution. So that's why option D is wrong and option C is the only right option. Question 82. Which statement about hydrogen and oxygen are correct? Now we are moving towards the fuel cells. Okay, that's the last part of electrolysis. Let's see, hydrogen and oxygen can react to produce electrical energy. Yes, that's right. In fuel cell, they produce the electrical energy, right? So this option is right. Hydrogen and oxygen can be made by the electrolysis of dilute aqueous sodium chloride. Let's see. It's aqueous. Of course, at cathode, you are going to get hydrogen. And at anode, if it is dilute, you are going, yes, it's dilute, you are going to get oxygen. So that option is also right. So D is the right option. 83. Hydrogen oxygen fuel cells and gasolines are used to power cars. Which statement describes an advantage of using hydrogen oxygen fuel cells in car in comparison with a gasoline engine? So you have to tell about the advantage. Hydrogen is a non-renewable resource. That's wrong. It's a renewable resource, so that's wrong, but it's also not an advantage, right? So if you are using that, it's non-renewable, it's not an advantage. Hydrogen is produced during the fractional distillation of petroleum. That's wrong. During the fractional distillation of petroleum, you get the short chain hydrocarbons or short chain organic compounds, but not the hydrogen. Hydrogen oxygen fuel cells do not release carbon dioxide. Yes, they only release water as a product. So this is the right option. Hydrogen oxygen fuel cell need electricity to work. That's wrong. Actually, they are producing electricity. So only option C is the right option. 84. Which statement describe an advantage of using hydrogen oxygen fuel cell in car compared to a gasoline engine? So the first is the hydrogen is difficult to store. So it's not an advantage. Of course, it's a disadvantage. So that's wrong. The hydrogen is highly flammable. Of course, it's also a disadvantage. It's not an advantage. The hydrogen, these are right, but actually they are disadvantage, right? So the hydrogen use is made from hydrocarbon. That's wrong. Hydrogen is made, and usually we get hydrogen from the electrolysis. The product is usually from the electrolysis or some other compounds we get it, but it's not only from the hydrocarbons. The only chemical product is water. Yes, that's the right option. So that is the advantage actually, that we have no harmful gases are produced. Okay, so we are not getting any harmful gases. So option D is the right option. Question 85. A fuel cell is used to generate electricity. Which chemicals are used in the fuel cells? Remember always the fuel cell is actually the hydrogen oxygen cell. So it will be hydrogen oxygen. Option B is the right option. Which gases are used to generate electricity in a fuel cell? Again, hydrogen and oxygen are the gases that will be used in the fuel cell. Option C is the right. Which statement about hydrogen oxygen fuel cell is correct? Hydrogen is extracted from clean dry air. That's wrong. The only product is carbon dioxide. That's also wrong. It's not the product. The reaction is endothermic. That's wrong. Endo is exothermic. It's producing heat and electricity. Okay. So no toxic gases are produced. That's the right option. Okay. So option D is the only right option. Which statement about a hydrogen oxygen fuel cell is not correct? So we have to find the not correct. So chemical energy is converted into electrical energy. Yes, that's right. Because chemical reaction H2 and O2 reaction is changing it into electricity, right? Hydrogen is oxidized. Of course, hydrogen when react with oxygen, it will gain oxygen, right? So getting oxygen is also an oxidation reaction because it will change into water. So that's right. The reaction that takes place is endothermic. That's wrong. It's actually highly exothermic. It will produce heat. Endothermic needs the heat. And actually this reaction is a fuel cell, right? It's actually occurring in the fuel cell. So of course fuel cell is giving you the heat. So it means this is wrong. It's exothermic. Water is the only chemical product. Yes. So that's also right. So option C is the only wrong option. That is, so option C is correct. 89. Which equation represent a reaction that takes place in a fuel cell? Of course, hydrogen and water reaction. We have to see where hydrogen and oxygen reaction. Sorry, I'm saying water. It's hydrogen and oxygen reaction. So option B is the right option where hydrogen and oxygen will react and the product will only be water. Question 90. Which statement about hydrogen fuel cells are correct? Water is formed as the only waste product. Yes, that's right. Both water and carbon dioxide form. No, wrong. Carbon dioxide doesn't form. The overall reaction is this one. Yes, that's right. The overall reaction is endothermic. Again, wrong. It's exothermic. So only we are left with option 1 and 3. So option A is the right option. Question 91. Hydrogen fuel cells can be used to power cars. Which statement about the fuel cells are correct? The balanced equation for the reaction is H2O2 and it will give you H2O. Is it balanced? I don't think so. It's balanced, right? It should be 2 here and also 2 here, right? So it's not balanced. The fuel cell generates electricity. Yes, its electricity is generated. In the fuel cell, a hydrogen is reduced. Wrong. It's oxidized actually. It will gain the oxygen, right? So oxidation is also to get an oxygen because the water will be the product. The hydrogen is added, oxygen is added here, right? So that's hydrogen is oxidized. The reactants are gases at room temperature. Yes, that's right. Both are gases at room temperature. Sure. So option 2 and 4 is right. That is C. So C is the right option. Question 92. Hydrogen is used as a fuel in rockets and is also used in hydrogen fuel cells. Which statements are correct? Both uses produce water vapors. Yes, of course, because if you are using hydrogen in the fuel cells, the product will be the water vapors. Burning hydrogen produce polluting gases. That's wrong. Only the product is the water. A fuel cell produce electricity. Yes, that's right. So option 1 and 3 are the right option. That is B. So B is the only right option. Question 93. Which statement about hydrogen are correct? Now, let's see, when hydrogen is burned, heat energy is released. Of course, when you are burning the hydrogen, heat energy will be produced. When hydrogen is used in a fuel cell, electrical energy is generated. Yes, that's also right. Electrical energy is generated in when we are using it in the fuel cell. So when hydrogen is used as a fuel, water is the only product. Yes, that's also right. So option A is the right option. Question 94. Fuel cells are used as energy sources in cars. Which rows gives a fuel use in a fuel cell and the products formed? So in a fuel cells, what we are going to use, let's see. So in fuel, usually we use hydrogen, right? Hydrogen and oxygen. So what are the products that are formed? Water is the only product. So option B is the right option. Question number 95. Which statement about a fuel cell in a car is correct? The fuel cell produces heat which powers the car. The hydrogen produces the heat, but fuel cell actually generates electricity. It does not produce heat. So it's not the heat actually that is powering the cell. It's actually the electricity that is powering the cars, okay? So the fuel cell is supplied with hydrogen directly from the air. That's wrong. We are not getting hydrogen from the air. The only emission from a fuel cell is nitrogen gas. That's wrong. From fuel cell, it's actually water, okay? The fuel cell produce electricity. Yes, that's right, which powers the electric motor. So option D is the right option. Question 96. Which statement about fuels is correct? Now it's only about the fuels. Coal and ethanol are the examples of non-renewable energy resources. Non-renewable energy resources means once you utilize them, you cannot get them back. For coal is right, but for ethanol, it's not right, because ethanol we can also get them from the process of fermentation. If you remember the process of fermentation, by use, and from fermentation you use glucose, and glucose will come from where? You can use any source. It can be barley, it can be wheat, or it can be sugar cane. Okay, and these all crops are renewable, right? So that's why this option is not right. Hydrogen and oxygen can be reacted to produce an electric current. Yes, that's right. Large amount of energies are taken in by a fuel when it burns. Large amount of energy is released, actually is not taken in, so that's wrong. Radioactive isotopes are burned to produce heat. Radioactive isotopes produce heat, but they don't need to be burned. They are already very reactive. So that's why this is also wrong. So only option B is the right option. Question 97. Which statement about fuel is correct? Again, let's see. Heat energy is only produced by burning fuels. That's wrong. Yes, heat energy is produced, but not only the source, because you can get the heat energy from solar system, right? Also from the solar system, also from the hydrogen and oxygen burning. Okay, hydrogen is not a fuel, right? So you can also get the heat energy from there. So there are different sources. So you cannot use that it's the only source. Hydrogen is used as a fuel, although it is difficult to store. Yes, that's right. We can use hydrogen as a fuel, but it is difficult to store. Methane is a good fuel because it produces, yes, methane is a good fuel, but usually we don't use methane. But it produce only water when burned. That is wrong. It not produce water only. It will also produce carbon dioxide. Uranium is burned in air to produce energy. It will produce energy, but we don't need the burning. Okay, it don't need to be burned in the air. So that option is also wrong. We are only left with which option? Of course, option B. So option B is the right option. Which substance does not require oxygen to produce energy? That's I already told you. Uranium is the one that does not require oxygen. It's a radioactive isotope, so it of course it will be producing energy without oxygen. So D option is right. Now diagram shows some properties of the substance may have. To which label part of the diagram does uranium-235 belongs to? First, use as an energy source. Yes, that's right. It's radioactive. Yes, that's right. It's a compound. That's wrong. It's an element, right? So this option is the wrong option. So where you can get these two options when where they are colliding only. These two options. If you see here, okay. So D option is the right option, because this D is where? This D is between this one and this one, because this C is touching this and this. A is also touching this one, this, and B is touching these two. So compound is wrong. So D is the only one that is just in touch with these two options. So D is the right option. Question 100. Okay. So this question is actually related to chapter number 5, but it was actually hydrogen oxygen fuel cell. So that's why I added this question in this chapter. Okay, so let's see the question. When a hydrogen oxygen fuel cell is in operation, these are the two reactions happening at. Okay, a hydrogen oxygen fuel cell is operated for a period of time and 4 moles of oxygen molecules are consumed. Which mass of hydrogen is consumed now? So before doing the moles working, we have to write the equation. Where is the equation? These are the half equation. This is not the actual equation, right? So we can write the equation for the fuel cell that we already know. H2 will react with O2 and you will get H2O, but you have to balance first. Before doing any calculations, you have to balance the equation. So the balance equation is like this, right? So now they are saying 4 moles of oxygen molecules are consumed and you have to find the mass of hydrogen. So they are talking about oxygen and hydrogen. So if you use 2 moles of hydrogen, you have to use 1 mole of oxygen, right? But if you use 4 moles of oxygen, how many moles of hydrogen you have to use? You have to use 4 twos are 8, yeah? Okay, so we have to use 8 moles of hydrogen now. So we have to find the mass of 8 moles of hydrogen. It's simple. So hydrogen has a mass of 2, right? Because it's a molecule. So 8 into 2 is equal to 16. So 16 is the right answer. Okay. So 16 gram we have to use. So option D is the correct option. Question 101. Hydrogen reacts with the oxygen in a fuel cell. Okay. 2H2 plus, okay, we know the reaction is exothermic. 286 kilojoule of energy is released for every 1 mole of the water formed. Okay, so for 1 mole it is actually 286 kilojoule. Which volume of hydrogen gas measured at room temperature and pressure would react with the oxygen with a release of 7,000 kilojoule of energy? So you have to find the volume of the hydrogen gas. It's a gas. I already told you the formula. Which will be the formula? Mole is equal to, you have to check the chapter 5 video. I already told you when there is a gases, you have to use this formula. Mole is equal to volume divided by 24 dm cube, right? So 24 dm cube, you already know. You have to find the volume. You have to first calculate the moles. How we will find the moles? Let's see. Because they already told you 286 kilojoule of the energy will be given with 1 mole of the water, right? So 1 mole is, if you use 2 hydrogen moles, you are going to get 2 moles of the water, right? So it means if you are going to use 1 mole, then you will also going to use 1 mole of the hydrogen. I hope this is clear. So 1 mole of hydrogen, if used, you will get 1 mole of the water and the energy will be 286 kilojoule. But now we have to decide for 7,000 joule. So 7,000 joule means 7 kilojoule, right? So let's see what will be the mole of the H2O. So if 1 mole is giving you 286 kilojoule, 7 kilojoule, how you will get? Just cross multiply. So 7 divided by 286 and you will get your answer. Okay. So how many moles you will get? It's almost, I think, 0.2 or something. I will use a calculator. I will show you. It's like 7. So it's 0.02447. Okay. So that's the moles of the water. So this mole of the water and the hydrogen moles will be same, right? Because 1 mole of hydrogen is giving you 1 mole of H2O. So if this is the moles for H2O, then the mole for hydrogen is also the same, 0.02447. So let's multiply with this one with 24 dm cube and see our answer. It's 0.587 dm cube. Okay. Do we have 0.57? No, we have 587 centimeters. So this is the right answer, because if you multiply it with 1000, it will change into centimeter cube. So 587 will be the answer you will get. Okay, so 587, A option is the right option. Question 102. The concentration and volume of an aqueous alkali are known. Okay, this is also from chapter 5. I missed this question last time in the video, so that's why I'm just going to revise these 2 questions. There is one more question and then we will end this video. So let's see, the concentration and volume of aqueous alkali are known. Which additional information is required to calculate the number of moles of an acid needed to neutralize this aqueous alkali? Okay, so it means an acid and alkali are reacting and it will give you a salt. Okay, right? So alkali, you already know the concentration and volume, right? So what you will get here, from here you will get the moles, right? So you also have to, you require to calculate the number of moles for acid. Now your target is just to find the number of moles. So once you know the number of moles of alkali, you will also know the number of moles of acid, right? So you don't need anything, any information about acid. You don't need any information. You just need to know about this reaction, right? So let's see which option is correct. The concentration of the acid, no, we don't need, because once we know the alkali mole, we already have the information related to the mole, right? So we will get it. The equation for the acid alkali reaction, yes, that's very important, because once we know the equation, we know the balanced equation, we will balance it, and from balancing we will know the number of moles. We will compare the moles of this one with the acid. So that's why this option is the right option. Okay, you don't need to look for other options. So option B is the right option. Let's see question 103. What is the concentration of a solution when 31.8 gram of sodium carbonate is dissolved in water to make a solution of 250 centimeter cube? right? So now last time I already told you there are only three formulas that you have to repeat again and again for the moles. So here if you see, you are given a mass. So it means you are going to use a formula of the one formula that you are going to use is mass, given mass divided by molar mass, right? That is one formula. Second, you are giving with the concentration. So the second formula that you are going to use is mole is equal to concentration into volume, right? So they are asking you what is the concentration of the solution. So you have to find the concentration of the solution if this is the one that is used and the solution is dissolved in a, okay, this is the volume of the solution. So volume is given 250 centimeter cube, right? Or you can say 0.25 dm cube, that's already given. But you have to find the concentration, you don't know the number of moles, right? So now we are going to find the number of moles through this formula. Given mass is 31.8 gram, right? And molar mass for Na2CO3 is how much? We have to calculate this one. For Na2CO3, it's 106, I think. 31.8 divided by 106. So is 0.3 moles. Okay, so if I use that value here 0.3, so if you multiply with 0.25, you will get 0.0. Wait a minute, let me calculate again for the Na2. Na2 is 23 into 2, right? And plus carbon is 12, and then we have 16 into 3. So let me calculate 23 into 2. We have to add plus 12 for carbon, and then we have to 16 into 3 is equal to 106. Yes, so now let's find the moles. Moles will be 31.8 divided by 106. So it's 0.3 mole. Okay, so 0.3 mole is what you are going to get from here. So now for 250 centimeter cube, if I divide it 1000, is 0.25. Okay, so 0.25 into 0. Okay, so this is now your 0.3 mole. This is your volume. Okay, right? So moles is equal to 0.3 moles, and then concentration into volume. Volume you already know 0.25 dm cube, right? And concentration you have to find. So this one will move here. So if you have to divide 0.3 divided by 0.25, you are going to get the answer is 1.2 mole per dm cube. That is the answer. So option C is the right option. Okay, so option C is correct. Question 104. The concentration of a sample of dilute aqueous sodium hydroxide is found by titration. The apparatus used is shown. Which information is needed to calculate the concentration of dilute aqueous sodium hydroxide in mole per dm cube? So the formula is simple. Mole is equal to concentration into volume, right? You need this formula for the for finding the concentration, right? So if you want to find the concentration, you should know the volume and you should know the mole of the NaOH, right? So can you find the volume of NaOH used? Yes, we have here, right? This one. But can you find the mole word? The mole of the NaOH? No, there is no option. Okay, so now from where I can find the moles? From the equation. If I know the equation of this reaction, how I can find? If I know the moles of the acid I'm using, I can find the moles of the NaOH. So what I need for to find the moles of the acid, I should know also the information, same concentration and volume of the acid. So concentration and volume of the acids, once I know, I can find now the moles of the acid, and from the moles of the acid from the reaction I will get the answer for the NaOH moles also. So where this one is equal, this one is right. Yes, these two, and this is the third thing I need, right? But this is not the thing I need. So this one cross, and this one is the right, and this one also cross. So this option B is the right option. Okay, so that's why option B is the correct option. So this is all related to chapter 6, and some questions that were missing from chapter 5 I also covered them from 2016 to 2024.